Hello, for this video problem we are asked to find the sum of these three force vectors here. So we've got a 3 kilonewton force, a 5 kilonewton force, and a 6 kilonewton force. And the first thing I'm going to do is to label these forces so I can keep track of them. I'm going to call this one F1, this one F2, this one down here F3. No rhyme or reason really to picking these labels, I just need to be consistent. So the first thing I'm going to do when adding up these vectors is I'm going to break each of these vectors down into x and y components. Once I do that, it's pretty simple to add them together. So force vector 1, I'm going to draw out my triangle here, and the hypotenuse of this is going to be the 3 kilonewton force, and the angle here is going to be 45 degrees. And so this is F1y over here. I suppose I should draw in, I've got my y direction and my x direction. I'm assuming it's horizontal and vertical, which is the usual order of things. Down here is F1x, and basically I'm going to use sines and cosines to figure this out. So F1x is going to be the 3 kilonewtons times the cosine of 45 because it's the adjacent side. And that is 2.12 kilonewtons. F1y the opposite side of my triangle, so it is going to be equal to 3 times the sine, 45, and that is also 2.12 kilonewtons. Alright, so that is x and y for force vector 1. Force vector 2 is pretty simple. It's 5 kilonewtons. And it is in the x direction, so there's no y component at all. So F2x is 5 kilonewtons, and F2y is going to be equal to 0 kilonewtons. Alright, moving on to force vector 3. So this one is going down kind of in that direction. And if I draw in my triangle, this right here is 30 degrees. And this is 6 kilonewtons. Alright, so now I can figure out F1x, or F3x and F3y. So F3x is going to be this piece down here. F3y is the vertical part. And so F3x is going to be a negative number. It's going down, and it's going to be the hypotenuse, 6 kilonewtons, times the sine, or sorry, it is going to the left, so it is negative, times the sine of 30 degrees, since it's the opposite side over here. And that is equal to negative 3 kilonewtons. F3y is the adjacent side, so it is also negative, it's going down. Negative 6 times the cosine of 30 degrees. And that number is negative 5.20 kilonewtons. Alright, so now I have the x and y components of each of those three pieces. So to find the sum, I simply need to add up all of the x component of the sum, I need to add up all the x components, and to find the y component of the sum, I need to add up all the y components. So Fx, this is the total force vector, is going to be F1x, and F1x was 2.12 kilonewtons, plus F2x. F2x was 5 kilonewtons, plus F3x, and F3x was equal to negative 3 kilonewtons. And so simply add those up. Remember to include the negative for this because it's going to go to the left rather than to the right. And I get a total value of 4.12 kilonewtons in the x direction. Alright, Fy, I do the same thing with the y components. And my original, for F1, I had 2.12 kilonewtons in the y direction. For F2, I had 0 kilonewtons in the y direction. And for F3, I had negative 5.20 kilonewtons in the y direction. And so if I add all of these up, I end up with negative 3.08 kilonewtons. And so this is my x component, this is my y component of that total or sum force vector. So F total is equal to 4.12 negative 3.08, and my units are kilonewtons. And so that is the sum. If I take the sum of these three force vectors, this is going to be that sum in vector or in xy in the xy system. So thank you for watching. I hope to see you again.